locked on here solid. We got our insert in here, and basically we just want to come across a couple face cuts here. So it does look nice and true there. We're going to set 0. Now I'm going to go ahead and cut from the inside out, so I'm going to reverse my feed here. Taking 25 thousandths off and we're not going to be real aggressive, even though we have that hard ring and we're biting on it pretty good. We don't want to take it for granted that we are sticking out quite a bit. Alright, we've taken one cut across here, and you can see this valley right here. Comes real close into that O-ring diameter there and there. This really is jeopardizing the whole the strength of the bolts, but more so than anything else, there is a little bit of corrosion in around where that O-ring sits in the bottom. So we're going to take it on down and get that O-ring groove completely below surface so that we can have some new material where that bottom of the O-ring is going to be seating around there. Now, like I said, there's only one cut, and so we're just going to take it down until we get pretty good material all the way around here. Then we might take a step in and cut where this O-ring is in here. And then the rest of it will be all rotary burr and setting up and doing that, or also setting it up in the end mill with a 2-fluid end mill and coming in on the side and cleaning it out. One way or the other, we're going to go ahead and come in with another cut from the outside so that we can create a cavity that we can get in there with the heliarc and weld those up. Okay, I think we're at a point where I'm just going to be coming in here and skimming a little bit out of this area where this O-ring is, because we're starting to get about 1/8 of an inch away from the wall of this thread here, and we've got good material here across to here. We can take and clean this out with a rotary burr around there, right there, and of course we're going to be opening up and getting some material down inside these bores here. So I think we pretty well have got that ring all the way around in there that we're going to have good material to build onto. These low-lying areas right here, we'll rotary burr those. We'll build those out to the surface. Then we'll be uniform on top of this and then adding. This is about 75 thousandths off of this space right now. So I'm going to reach in here and we're just going to take a little bit more material so that the bottom or the inside of that O-ring groove is going to be fresh new material. And we're going to touch that groove so that we know kind of the depth that was from our, at least within a couple thousandths of where it was at from touching. Right there, which is about 83 or so. So it's probably set for the amount of compression for a 3/32 O-ring, which we'll measure the O-ring and all that. It might be a metric ring as well. So okay, I just did that by hand, just so we can get down in there and have some good new material right there. I've been cutting this dry, so we got like a frosty color on here, but I don't want to introduce any fluids, cutting fluids and things like that. Some of them I know can weld fine, but this is cast aluminum and it is one of the toughest aluminums to weld on, and especially your first pass coming onto here is either make or break the job. So we're giving it the best chance we can. All right, I'm ready to pull this out, and then we're probably going to set this up probably in a mill, because I think I'm gonna want to take and come in and gingerly open up these 4 openings for the threads there. Come in and completely clean them. All right, we're getting ready. We've cleaned off this side of our mill table here with chips. We had some chips in here from milling stuff. We don't want to mess up and move our vise here just to come in and whittle a little bit of relief and clean up the area for our holes here. So what I usually like to do is, and we're going to leave that ring right in there. I think that ring will stay right in there until we're just about done with the whole job. So we're gonna put that down there, and I just go ahead and I get a T-slot. I'm going to go ahead and put it on the bottom here. What I did is I kind of sized this up and went like that, and I said, okay, those two will match up, and I just picked them out. So I like to put this down. This is a extra long nut, or a coupling nut, and we go ahead and we screw this in here like that real quick. All right, and slide this down here. We slide our part over there, and we want to come over here towards the middle of the table because we're going to be pulling out this drill chuck. There we go. We're going to come in from this side here, and we'll be able to whittle that away. We're going to go ahead and we'll start on this corner here. So I'm going to set this up kind of just like splitting the difference so the stud and everything else is right in the center. We run our clamp upside down. It's kind of like our helping aid of keeping the bow out of the clamps. Tendency once in a while you might have a little bit of a heavy hand on tightening up a toe clamp. And all right, snug that up. All right, we're going to go ahead and we're going to pull our chuck out, get ourselves a 2-flute end mill, something that we can come in here and cut a nice pocket in where that thread is, so we'll be able to get in there with our small TIG torch. We found a nice 1/2-inch 2-flute. It's not brand new, it's been used before. It's not a ball nose, but it does have a pretty good sized radius right here on the edge, so we're not going to have any real sharp square corners coming in here, but we'll be able to get in there and create a surface that we can probably flow our aluminum into a pocket pretty comfortable with that amount of radius on there. I'll take a look. I'm going to cut into it. I'll be taking a look and we'll see if I really like that or not. All right, let's change some speeds and feeds around here. We can get it up here, something like that. We can lock that. We're gonna lock our feed because sometimes we like to adjust with our crank of our dial there. Semi-tension, our knee coming up and everything else, just because of all the backlash and play we have. Okay, we're gonna come up on our knee a little bit. Okay. All right, let me bring you around this other side here so you can see. Alright, now we can get in there with our heliarc TIG welding, and we'll be able to go around and start at the very bottom, bring in a nice root pass, and we'll build this boss straight up out of here. Alright, so now I'm going to go ahead and rotate this around 90 degrees. We'll hit this one, 90 degrees, we'll hit that one, 90, so on. Alright, now get the vacuum and sweep all this up here. Alright, all four of them are done now. Now it's time to go ahead and take the rotary burr and come in and just hit them low areas along here. Any of those areas that have a little bit of corrosion or erosion and have been sandblasted, we want to make sure that we get all the silicon sand or any of the blasting materials out of those areas. But each and every one of those threaded areas is completely cleaned out and ready to receive some new material. We've got our table cleaned off and kind of like all the dust and everything else. Even though I'm going to make some more, it's like I got to start fresh, and that's kind of why my settings always look kind of clean, because I don't want to work in a hellhole anyway. And so I got this set up in here, and I've got the jaws out here. I kind of played around. These three are equal because this is the curved section here, and that's pretty well equal all the way around. So once you get side to side, you kind of know where this is at. And then I had to decide whether this jaw was actually going to have enough engagement or whatever. Now, we're not spinning this thing high speed, so we're not worried about this thing flying out, but it does heat up and it does contract. So if I'm going to crank it on down or whatever in different positions, I don't want it falling out on the floor. And of course, that's where that metal ring also helps us, so it gives us enough thickness and girth into the section in here to where that is going to hold without deforming, cracking, or breaking that thin wall right there. Alright, so I'm kind of happy with that, and we'll just go around here and okay, we're stout. Now we're going to go ahead and we're going to set up our rotary burr, and we're going to grab our face shield. We'll probably have to clean that off as well. And all of the areas that are joining or mating that milled out surface, even this area down here where I don't want weld, I'm going to take the rotary burr and I'm going to take that little shell off of there, because aluminum has a tendency to reach out right past the puddle and suck the poisons in and whatever else is out there. And if sand and surface silicon, whatever they blasted, whatever they did cleaning, will get sucked into it. So, and this is cast aluminum, and of course I haven't even struck an arc on here, I haven't even tested it. But you're right, the most cases of cast aluminum, it's not very friendly to weld. But by doing what the customer did for me, getting this thing immaculate on the cleaning, coming down, facing off the top here, cleaning out where we're going to have that inner O-ring groove there, milled out the pockets, so we got rid of the helicoils and the threaded area that the helicoils set in. It was developing a little bit of corrosion. It wasn't bad. It wasn't extremely bad. If none of this other stuff was gone to where it was, the integrity of the O-ring seal was still making, hey, let it fly. But it wasn't. It was getting very, very sketchy, and it wouldn't have been able to go much longer without having catastrophic fail. So anyway, we're giving it our best attempt to go ahead and save this project. Now we know that we're going to be probably contracting. This bore is probably going to get smaller. We're already anticipating that and how much, and we'll be able to skim and get that set up. There is clearance in here for the actual inner pack, the tube sheet and tube assembly that will slip in here, and it really, it's got to only seat at the O-ring at both ends. The middle is kind of clearance. So as long as we maintain and don't exceed that clearance, we'll be fine. We'll be able to and keep the integrity here and relocate these 4 bolts, which are holding a floating collar basically that holds the head on this end here. Alright, so I'm going to get my gear and we're going to start doing a little rotary burr and cleanup, and so I'll give you a little bit of that. You don't need to watch too much of that, I guess, and you've seen me do it before, and maybe hit a couple close-ups and stuff like that to show you what I'm expecting to clean up in the area around the surface when I'm ready to go. Okay, we're going to work our way around this, and we're taking down right next to here any of the material that's gone on that edge, and also like right through here. Okay, we're going to go down, we're going to take that all the way down to where we don't see any more of that, where we got the rotary burr surface and kind of smooth. And then this outside edge here, we just kind of roll it over, just making sure that we're getting the outside off. Now we're getting a little clogging on here, so we're going to go get a brush too, and we're going to probably go get another piece of aluminum so we can dab some aluminum tap on here and clear those out, blow it clear, and then go back to it. So we keep a clean head here without transferring too much poisons to the base metal. Okay, we've gone around, we've rotary burred around our entire outside, caught those areas right in there, and now we're just going to go ahead and make sure that we have everything clean. A little bit of acetone just to go around, and basically anything is basically our finger oils and stuff like that's the only thing left on this thing. Alright, we're going to get in a comfortable position here and get set up with the heliarc, and that's, we mix our helium in with our argon, and I give it just a percentage to flow in there, and it really does help. And so I'm going to get this to where I'm comfortable, where I can get set up and I can work it in all positions here. It just seems like when this is up like this, which most or some of my welding is going to be, this is a bit high. I may get something to set it on, but we'll give it a shot anyway. Alright, I'm just going to be warming this up here. I'm just doing it barehanded to where I just barely can't hold my hand on it, and then that's about the temperature. This is a thin wall casting. I just want to make sure that the whole thing is expanded, so as I'm welding here, and I'm going to be filling in these major voids here before I go for the face of it. much because it's lightweight, but you can hold your hand on there for about a quarter of a second. All right, let's get our torch leads and stuff here. Hey, before we fire up the welder and create some noise here, I'm all set up. I got my gloves. I'm gonna do it here. I'm gonna work here, and I got Jody's TIG fingers so that I can prop up here, and I think I'll manage being able to stand up and actually get right here. It'll be in my face, and I'll be able to. We're going to see how comfortable I can actually get here. I'm right-handed most of the time, so I'll probably be off on this side here as well. The rod I use is 4643. Alcotech makes, there's the brand name on the box I have. 4643 is a rod that is developed where you have minimum or little dilution of your base material, and you want to build up and you want to keep the integrity of the material that you're building up, so that when you shape out that material, the combination of joining it and itself will maintain a proper strength and shape and all the other properties that go along with this kind of a repair. It has worked for me really well in the past on a lot of build-ups where I was just connecting with a knife edge. I say knife edge, but you know, a real narrow section, and then create a shape off to the outside of that joining area and come out really well and holding up and strong, and the bond is good, and so that's what the rod is I'm going to be using. It's nothing. It's not top secret or anything else like that, and I'm glad to share. There are a couple other rods that are the same. Jody works with a couple rods that basically about the same purpose. So there's not just one alloy in that area. There's several of them. Okay, I'm going to start on the pockets. I'm going to weld up the pockets and create that flange area basically on up to where I'm up to the surface here. Then we'll hit a couple of these little small valleys that are right in here, and then after that, then we're going to set it up and we're just going to start spiraling around, and we're going to build the height up here. And it's not a race to get on as much. It's precision bead laying or drip castle making, metal castles, you know. So anyway, let me grab my hood and flip on the machine, and we're going to get on our way here. It is a little rough to get in there, but what I do is I work out here. I work out here on the edge here, and then I kind of work on my way in here. And you'll see the gloss come inside there. And it's not so much of the add rod. I mean, that does top off your amount of material you're putting in there, but you want to make the base material come in and fill the pocket. Every little step of the way, you've got to make sure that material is coming in from around the edge and fills the pocket. Do not try to just put a dab over and put a dime over a hole. Okay, you want to make sure that hole flows in from the side and flows down into the pocket itself. And you'll end up having something that looks like that. It's a nice oval here. And see, we're starting to get room in here because you're working a torch and I'm working a number 7 tip, and I'm getting in here on something that's just as wide as the tip. So, but I have a little bit of stick out here, and I just make sure that I have enough gas. I like running a ball tip on my tungsten for AC, high freak welding. This was just running another pass. So the aluminum weld is really nice doing an uphill or a vertical, and I'm able to set my puddles back in here and keep joining and making sure that it's solid underneath there. I'm going to let this one rest a little bit. I'm going to come over here and I'm going to get started on this one over here so I can kind of like spread some heat out. Here's a look at this side in here. See, I sacrificed a little bit of this. I let this like roll on in and then just carry the wash. Now it was like really stubborn right in this back area, right in there where you're about ready to make that corner around there. It's real stubborn, but you got to stick with it. You got to stick with it. And sometimes doing just a little bit of a side rock will get that puddle to go and right in there. And once it has that with its own base material, then you can successfully build on it. And lots of time, this is actually welding pretty smooth so far. Just my couple little welds right here, I can pretty much tell that this job, as long as I keep it under control, not getting away with the heat and not overpowering the torch and the amperage, and do some nice finesse dripping, I'm going to have a pretty successful job here. We're about 30 seconds from coming all the way in here. This looks good down in here. So we got a little bit more to add in there. You want to put a little bit more down here where you think you need it, because it's better to be looking at it than looking for it. This right here is almost, this is actually a little high right here, but this is a little bit low here. So the same thing right here. This is nearly complete on the sides. This is looking good. There is a slight radius out here, but you want this sticking out more material so that when you finish this off right here, your lower and upper corners are square out to the take up the whole surface. All right, I'm going around and I'm just kind of like looking at the side views right here, and I'm pretty happy that I have enough material coming out along the outside edges. Nice good bond, and I also I'm happy with you always have on your fresh weld, and usually when it's taking real well, you have a nice gloss. You have a little bit of cloudiness every once in a while, and you get a little bit of pregnated crud within the casting material, and it is porous, and you know, I mean, some of that might even be some of the oils and stuff like that over the years that this thing's been in service, just caught in the pores. But it comes out and it's bonding and it's looking really good. So it does pay to really clean your project up before you actually start with the welding. I also have a little stainless steel wire brush, and in between the passes or the beads, you go ahead and you brush some of that stuff off, and by getting that off and out of the way, you don't tend to carry it on to the next part of your weld. Now, we're going to lay this down, and I'll probably be really smoothing out some of these outside areas, but right now I'm pretty happy with how I filled those cavities in. And I work from the bottom up, so it's a vertical weld, so stacking the dimes, so to speak, on top of each other. You coming in, making sure that you join to the inside of that pocket, and then I just kind of space it around, so we're not burnt through or anything else like that. We're not putting in that much heat, just enough to work the local areas there. Alright, I'm going to go ahead and I'm just going to touch these little low valleys right up here right now, and I'm going to roll it over to the side, and I'm going to take another look at from the other side. So I'm not sitting here and go like this. I can lay this thing down and really look at it like right down on the top, and then I can play with that a little bit. Now with this laying down here, we're able to really get a good look at this back side here. We're kind of just going around here real quick and just getting it nice and clean. Sometimes cast tends to do this because you got little tiny dirt pockets that are out here, so you have good bonding, and then you have a little area that has like a little hole or whatever. Sometimes you can get to this point here, and then you take your rotary burr and you kind of like brush that again, and then you can come on over and it'll flow. But don't get disappointed. Don't try to chase it on off of there. There's nothing wrong with that. That just happens to be the little dirt. That dirt, like right there, is a little spot right there. That's going to be the same thing as that right there. If you got out there, you're going to be dealing with that one there. So, you know, you got to draw your line in the sand and how far you want to go. Just like there's a little spot right in there and right in there. And the same thing, a little rotary burr, and then I can get that to flow in there. We are going to be, I took a little bit of this material down in here because this edge right here is really, this is where it was eaten out. So I want to make sure that I got a good beat going along this edge right here. So I may, when I get ready to dress this, I might do that. I might lay one bead around in here so that when I start stacking them out that way, which we got 100 thousandths, a little bit thicker than the width of this rod, that we actually have to have finished material sticking out there. I'll get you a view coming in from this side here once around so you can see how that lapping is coming. And this was the bottom side, okay? This was hanging underneath as I came in and worked the sides. Alright, I'm gonna roll it over, but you can see how actually smooth I was able to bring those and meet those. And underneath here, you know, I was trying to come up and underneath this edge right here, kind of like hold that in. Now that I have it laying in this area right here, I can run a bead and have it just flow right in there. Same thing, I did this. This is actually a little bit more material here than originally. This radius right here kind of went in that way and then that way. So there's a little bit more. There's nothing wrong with having a little bit more material. I'm not going to try to get it all out of there and create exactly the shape. I just want to create exactly the amount of material out around the outside of the bolt pattern and a smooth face to make the seal. There's another one of those little dirt inclusions, or the stuff that floats in with the casting material. And there's a little bit of oil that, you know, you can see that the thing still has some gunk in it, even as clean as they got this. Here again, right here, and now I'll be able to reach right in here with a torch and just come in and give this a beautiful blended smooth face. But that's how the underside of my beads, as I was laying them in, Alright, real happy with the job so far. Alright, let's continue adding some on. Okay, we're taking a look across here, and of course it says 9.5 or so on that side of the scale, but I'm reading, you know, the height from this side, which we want 8 inches for 70 or something like that. So I'm kind of checking all the way around here, and we are almost at 8.5 as far as the top of this weld right here. All right, now we have a couple little lows, like right in here, so we're gonna try to hit those little areas right now, get those filled in, and then we're gonna start laying in beads around this outside face here. Alright, let me make sure the screen is clicked on. There we go. Because that's been the problem with a couple times there. I go to give you a window and it doesn't change. Alright, here we go. Okay, one last little spot here. We're going to regroup and switch positions here. Okay, I shut the welder off for a little bit here, just so we can have a little conversation here. I've tilted this down. I got a toe clamp down to the table so that my reach and everything else on my comfortableness of my hand position and welding will be great. And I've kind of tested this out, and you know, my leaning post here just kind of helps me keep steady and stuff. Now this inside surface right here, and I'll get a couple good still shots of this area right here, and I'm going to go ahead and I'm going to take the rotary burr and I'm just going to kiss that little meeting edge right inside there so that I can concentrate a nice, I call sealing bead. Yes, sealing bead, which seals all the little laps, making sure that everything is blending 100% solid. There won't be any flaps or laps. Alright, that should be taken off just enough that we can create a nice, sharp, clean, solid material bead right there. Alright, let's see how well we do with this position here. Alright, here we go.